All right, so we're on to section 1.4. There's only 5 sections this chapter, so we'll get through all the sections this first week, you guys, and then, like I said, next week will be a quiz and some review on the live Zooms and some chapter review on the live Zooms, and then the chapter test next Friday. Okay, so we're going to talk about limits of trig functions. So we're still living in this limit world. We learned about direct substitution. If you get an indeterminate form, you do 3 things, right? You try to factor cancel, you try to rationalize, or you try to simplify complex fractions. And so what you want to remember and what's going to give you confidence on the AP exam is that you still follow the procedure, right? You plug in 0 to a limit. If you're thinking about the limit as x goes to 0, if you didn't know anything what I told you, you would just plug in 0 and you'd get sine of 0 over 0. So pre-calc, remember, sine of 0 is an angle, right? This is asking the sine of the angle 0 in radians, which is right here, and that's the 0.1 comma 0, which is cosine sine. And so the sine of 0 is 0. And so we get this indeterminate form here. Well, we can't factor cancel, we can't do anything. So you are going to memorize this until I give you a reason not to memorize it. Okay. Similarly, you guys, if you have the limit as x approaches 0 of x over sine x, that's also equal to 1. Okay, so you need to memorize that. Now, if you memorize just x over x, you're going to get super confused here. Okay, and so what you really want to think about in your brain, and this really is helpful in higher level mathematics, if you guys see a theorem like this, what you want to memorize is that the limit as x approaches 0 of sine of some box, right, over that same exact box would be equal to 1, right? It doesn't have to be x over x. It could be dog over dog. It could be 4x squared over 4x squared. If you have that ratio, okay, you're going to get this value of 1. And so this is just an algebra trick here, right? So let's look at this first example. Let's take the limit as x goes to 0 of sine of 3x over x. Well, this box thing didn't happen, right? The box is 3x. And you can't change an argument of a trig function. So, that's where you want to start. You really need this to be what? What do you need there? You need a 3. So put it there. Well, you can't just magically put a 3 in a denominator and think it's exactly the same. But what if I put a 3 up top? Now we're good to go, right? This is a fancy form of 1. And 1 times anything gives me exactly the same thing. And so now I have the limit as x approaches 0 of that 3 times sine of 3x over 3x. Okay, this is legal algebraically because those could cancel out and you're back to where you started. Well, why is this helpful? Because now I have that relationship, and that relationship approaches a value of 1. And so the limit as x goes to 0, that whole thing is 1, and 3 times 1 is simply 3. Okay, you could check graphically and plug this in, and you could see that as I get close to an x value of 0 on this function without the 3's, right, you will approach a y value of 3. Okay, well, what about this guy? This guy looks like a disaster. And it is, if you're not good with algebra, and the hardest part of calculus is algebra. So you guys need to remember that this is the same thing as asking the limit as x goes to 0 of sine of 5x over something, call it 1, times 1 over sine of 3x. This is exactly the same thing. Okay, and so splitting that up, I think, is going to be helpful because some of you might recognize now the box goal, right? Look at the argument of the trig function sine. What is it? It's 5x, which means what do I need right here? Well, I clearly need a 5x. But I can't just put a 5x in the denominator. That changes the whole function. So I have to put a 5x over here somewhere so that theoretically I could cancel those. Same game. Look at that guy. That's 3x. Well, I need a 3x here. But I can't just put 3x in a numerator, right? Unless I also put it as a denominator so they could cancel. So let me clean this up. We have the limit as x approaches 0 now. I've got this 5x over 3x. I've got sine of 5x over 5x. And I've got 3x over sine of 3x. And you should verify with your own brain that this is exactly the same thing as that. How is that even possible? Because those would cancel and those would cancel and those would be that rational expression. Okay, why is that helpful? You've done your trick. You've gotten that relationship, which we know both approach a value of 1. And so the limit as x goes to 0 careful here, the x's would just go away. And so all of that just equals 5/3 because your x's can cancel. Okay, so it's just an algebra game. It's not too difficult. Okay, and then what we're going to do is we're going to investigate some of these limits that all of our strategies fail. So if I plug in 0, I get undefined. Okay, and when you don't know, you should check one-sided limits. So in theory, what's the limit as x gets close to 0 from the left? Well, again, there's 0 on a number line. I'm coming in this way. Well, what's a number that's really close to 0 coming in from the left? -1 is really, really far away, you guys. Okay, so you have a negative tiny number. So what is 1 over a negative tiny number squared? Right? That's really what you're trying to do. This is not official calculus, but this is how your brain has to think about it. Well, what's a negative tiny number squared? Well, no matter what, if it's squared, it's going to be positive. So what's a tiny number? Well, I guess just to keep it simple in your brain, negative tiny number squared. Okay? That is a really small number, right? That's 1 times 10 to the negative 10. And so what happens when you have 1 over, we just said that that's a tiny number. How many times does a tiny number fit into 1? A lot. And so the answer is infinity. Okay? You might want to rewind that again. Okay, let's do the other side, and then maybe that'll solidify it. Now let's take the limit as x gets close to 0 from the right. Well, what's going on here? I'm plugging in a positive tiny number. So I'm plugging in a tiny number in my brain, I'm squaring it, and what happens when you have a tiny number like 0.1 squared? It gets smaller. So you end up with 1 over a tiny number. And what is 1 divided by a tiny number? Well, what's 1 divided by 0.25? 4. That's not infinity. But what's 1 divided by 0.001? 1,000. And we're way smaller than that. What's 1 divided by a tiny number? It's massive. Okay, so when you take a numerical value and you divide it by a tiny decimal, you get a really big number. Okay, and so that's infinity. Well, what do we know about our one-sided limits? If they're the same, I now know that the overall limit as x approaches 0 of 1 over x squared should be infinity. Okay, and I think we could quickly just graph that, right? You might even know what that looks like. Let's go clear out all this stuff, and let's do 1 over x squared. Zoom 6. And what's going on as I get close to 0? Clearly, it's going up to infinity. And from pre-calculus, you would have known that this rational function right here, 1 over x squared, has a vertical asymptote at 0. That's what that is. Okay, but the limit, right, it still exists because our fingers are both pointing in the same direction of infinity. Okay, and that will not happen here. So let's now, this should go faster. Let's check the one-sided limits. What's the limit of this guy? Right, from the left. Well, remember, you're coming in from the left. It's not like this function where you square it. And so you get 1 over a tiny negative tiny number, which is going to be negative infinity. It's still infinity because this relationship of 1 over a tiny number gives you infinity, but because it's negative, you have that. And then what's the limit as you get close to 0 from the right? Okay, so you're coming in this way. Well, if you plug in that way, it's just 1 over a tiny number. And we talked about that relationship gives you a value of infinity. Okay, so you're coming in positive, you don't have the negative. And so what do you know about the overall limit? The overall limit as I get close to 0 here of that function 1 over x does not exist. It does not exist because we had that theorem that if the one-sided limits don't equal each other, the overall limit doesn't. And so what happens here in this function, when you delete that, you get this relationship where from the left, I'm going, down, and from the right, I'm going up. My fingers are not pointing in the same direction, therefore the overall limit does not exist. Okay. All right, just some quick practice here with going in towards positive 3 from the right-hand side. And so what is that going to be? That's going to be 2 times, let's just plug in a number for your brain, 3.01, right? Plus 1 over 3.01 minus 3. Okay, and we could get way smaller than 0.01, right? But this is just to wrap your brain around it. So this is going to be 6 and some change plus 1. So it's going to be 7 point, who cares, right? This is just basically a number, okay, over what happens here. 3.01 minus 3, that's 0.01. Well, what if I added a 0 there? It'd be even smaller. 3.0001. This still stays a number. This gets even smaller and smaller. So you end up with a tiny, positive, tiny number, right? Because this is always going to be bigger than 3. Well, what's our relationship when you have a number divided by tiny number? That goes in there a bunch, and so your answer there would be positive infinity. Okay? All right. Page 2. We've got some different limits here, okay? And we've got some limits at infinity. Okay, so I'm going to zoom in here, and we're just going to get into some number theory stuff here. And, this is not too hard. And again, all of this is to expose you to multiple choice style questions for the first 10 questions on the AP exam. There'll be a couple limit questions. So direct substitution says that I should consider 4 over infinity squared. Well, infinity is ridiculously big. Infinity squared is ridiculously big squared, which is big, okay? And so if you have 4 over a huge number, right? I mean, we can do this a couple times until you're comfortable with it. What's 4 divided by 10? It's 0.4. Well, what's 4 divided by 100, right? So if you do 4 divided by infinity squared, it's way bigger than that guy, and that's as close to 0 as you can get. And so if you have 4 over a huge number, so if you have a number over huge number, you get 0. Okay, this is a limit process. As you approach that value, that relationship approaches 0. Okay, so what happens if you have this? Well, what happens if you have negative 10 over the square root of infinity? You guys, infinity is so big, the square root of infinity is still ridiculously big. And so this is a negative number over a huge number, which you don't want to say negative 0, right? But this thing still approaches 0. And I could do that with the same example. If you take negative 4 and divide by 10, you're at negative 0.4. Or negative 4 divided by a huge number, it's still tiny. Yes, it's negative, but it's so ridiculously close to 0, you just write that the overall limit is 0. Okay. And then we can use that idea, right? Direct substitution. What does 2 plus 3 over infinity act like? Well, this guy approaches a value of 0. A number divided by a huge number is 0. And so 2 plus 0 would just give you a value of 2. Okay. All right, then we get into this polynomial thing here. And I'm going to do maybe a little sidebar, a separate lesson on how you would do this in an actual UCLA calculus class, because the Bruins are awesome. And we're going to just kind of cheat, because I know for sure this comes up as a multiple choice style question. And so you just have to think about the fact that as you approach infinity, this does not matter, that does not matter, and that does not matter. How come? Because x squared is so much, infinity squared is so much bigger than infinity. I know that's weird, but it is, that you don't have to pay attention to anything other than these lead terms, right? That's really what's going to affect what happens here. And then if you take the limit of that guy, these guys would just cancel, and you end up with a value of 3. Okay? And so if I quickly come in here, and I'll do a more mathematical definition of that in a separate video here, but if you end up with this rational function, 3x squared, y equals 3x squared minus 2x plus 8 over x squared plus 1. Okay, and you do zoom 6, which is not going to be helpful. Okay, what's happening to the function? Remember, as x approaches infinity, well, we have x is going to 10 right here, but I'm already looking good. If I jump on here and hit trace, okay, and I'm not even near infinity, you guys. I'm only out at an x value of 4 point whatever. I'm getting closer and closer to a value of 3, right? And you can see as you continue out, that value gets closer and closer to 3. Okay, so when you're analyzing polynomials, you want to only focus on the lead terms, the highest degree terms in the numerator and the denominator, and then analyze just that. So down here, right, we now know we should not be thinking about that at infinity. You really want to take the limit as x goes to negative infinity of 4x squared over x cubed. Well, in your brain, what happens here? Good old math, right? Some of those x's cancel, and you end up with 4 over x. Okay, so what you're doing is you're simplifying the process in your brain to what's really going to affect the numbers as you get very large. Okay, and so now you're thinking about, well, what does 4 over negative infinity look like? Well, infinity is a huge number. 4 over a huge number really acts like 0. And that would be your answer. If you graph this, you could see that as you go way left, you're getting close to the x-axis. Okay. All right. Then we throw in some square roots. The process is very similar. You know that this guy is the most important, right? And so is that. So don't care about the 10 and the negative 5. This is a lot of calculus that would have to be done if you were going to do this as a free response problem, but that's not where it shows up on the AP exam. Okay, so you're going to take the limit as x goes to infinity, and you're really analyzing the square root of 4x squared over x. Okay, well, what does the square root of 4x squared become? Hopefully you're good with your brain, says, look, that acts like 2x. And then the x's cancel. And the limit as x goes to infinity of 2 is just simply 2. Again, I encourage you guys, go plug that in your calculator and make sure that as you get large, as you go to the right, this whole function is approaching a y value of 2. That's all we're saying here, this limit process. And maybe it's starting to make a little more sense now. If not, that's what the zooms are for. Okay, guys? All right, one last one here. Again, 4th degree, 2nd degree, don't care about it because infinity to the 4th is going to trump, right? No pun intended there, this little guy of x squared here. And we get the limit as x approaches infinity of, we now know the main thing there is 5x to the 4th and 2x squared, which acts like 5x squared over 2, right? And then, well, what happens when I plug in infinity? What does 5 times infinity squared over 2 look like? That's just a massive number. Cut it in half, it's still massive, okay? And so as you go to the right, you are growing without bound. Right? You are just going up and up and up. Your y value is approaching a value of infinity. Okay. Again, I know that these lessons are tough. The good news is you guys can rewatch them. Circle things, right? Make notes as we do this. You guys, we're all learning as we go. But hopefully, these are questions that you can ask yourself on the live Zoom call with me, and I can make up lots of questions to help you out. And we have all next week to review. Okay. I hope you guys are doing well. Always remember to email me if you have questions. If you're feeling down about everything, you just want to chat, we can set up a Zoom call. I'm here for you guys. So just keep up the good work. Okay.